So this is the place where I've been documenting pretty much. I have like a doc where I have a bunch of long form stuff, but this is the concise information on the Readme. That's what Readmes are for, to describe what the code is and how to do stuff and whatever extra stuff you want to do. Basically, elaboration on the comments that can be in code. And I've updated everything for v4, even though it says testnet here, it is v4. And I added a bunch of stuff yesterday. It's like one thing I worked on was I've had Vince and Juyung and others reach out, and I've been helping back and forth on some stuff. And they actually was great feedback for me to understand what problems people are having, what questions they have, what things that I think, oh, that's easy, but for someone who has never did it before. I've been working on this stuff for 2 or 3 months. So I started with the Ethereum testnet scripts. A lot of them were originally made for that. And then when PulseChain testnet v3 came out, I just converted a lot of my Ethereum stuff over to PulseChain, tested all that. And then v4 came out, again, retested it. And I've got a lot of help too from Gamma DevOps' channel, his channel, Pulse Dev channel. Shout out to them as well. A lot of good conversations happening in there. So I'd recommend that. I'll put that in the chat. If you're not already in there, at least join the Pulse Dev chat if you do Telegram. Goes a lot of conversation and stuff in there going on. So this is the main page. This is just kind of like a screenshot here of things working. That was for v3. v4, like I said, everything's been updated. And I want to run through. So I'm not going to do a demo on a live server, but I found there's an online website where apparently it'll let me download stuff, so at least I can run some of the commands and show you what to do, how this stuff works. So I recommend you read all of this. I literally try to put it, all of the things I could think of to help you understand what this stuff does, how to run the script. The first thing is when you run the script, you need your Ethereum fee address where you want the fees to go. So you need to have a wallet that's ready that you control, that you can set your address to. So your validators and the stuff can be paid to. And then your server's IP address. And if this changes, you need to update the stuff too, which I have that in the FAQ section. But these are the only two things you need. When I was building the script, these are the only two things that need user interaction as far as that are specific for setting up your server that I found. And I've tested it. And that's the only two things you really need from a person setting it up. So here's the stuff. There's also scripts to reset the validator. And I have a space here, otherwise that should have been bolded. So there's a script for that this one too. It basically, if you want to run it a few times, I know some people have ran it a few times and now they're getting different errors. That can happen because when it creates the service files, for example, it'll just keep appending to the service files, and then it'll basically corrupt your service files for the PulseChain client stuff. Nothing system-wide, but just for the PulseChain stuff. So this is something, if you want to use the reset script, if you're going to run the script over and over, I recommend using the reset script, because all it does is, if it stops any of the services you got started, it will remove the service files that got created. It will remove the blockchain data, and it will remove the user. So it tries to make it as if you never ran the script. I guess it can't do it. It doesn't reverse everything. It doesn't reverse the dependencies you installed that the script does and stuff like that. But this will give you an idea of how to reset the client data and all that. To use the script, very important. I didn't want to just maybe I'll change it later, but I thought, hey, I want you to actually read and understand what the script does, so you don't run it on accident and it deletes a bunch of your blockchain stuff, and you don't want that. So all you have to do to run the script, if you run it as it is, you download it, you run it as it is, it will just say this. It'll say, turn this to true. All you have to do, edit the code really quick, change false to TRUE, true. That's all you need to do. You do that, it'll bypass the check, and then it'll ask you just hit enter to continue, and the script will run. Just wanted to put a little safety check in there, just so people actually take a look at the code real quick. Super simple edit. You don't need to be a programmer to do this. You literally just got to change this word to true to run the reset script. So again, I'm going to go through this and I'll get to questions in a bit, but I want to run through the meat and potatoes here. So the first thing So this script assumes, my tagline for it is it does 85% of your validator setup. And I kind of just roughly came up with that number because it does everything except create your deposit keys, which you should do on a different machine anyways, and make your deposit at the launch pad. That's pretty much, it does everything except those two primary things. So that's why I came up with roughly 85%. It automates all dependency installs. It automates getting your services set up, getting your other user to run it as for various security and otherwise reasons. It doesn't do Docker. I know a lot of people have been using a David Feeder script and other stuff to do Docker. This one is a not Docker version. There is advantages and disadvantages using Docker to run the clients and just running them all on the same server. There's advantages, disadvantages to that. I've never set up Docker with clients. So if you have any Docker related questions as far as the clients go, I'm not going to be very helpful because I have not tested that environment. I know how to use Docker. I've kind of helped people troubleshoot a little bit with some of the stuff, but that's not what my script does. So I'm not going to be able to be super helpful for that. All right. So the first thing you want to do is when you want to get it on your server, you need to have Git installed on the server, which may or may not be pre-installed already. And if it's not, if you're on Ubuntu, you just do, let's see. So this is just like a test terminal. This is not a real server. I mean, I don't know. I think it's like an emulation, or maybe it's a real server somewhere, but this is just something I could use in the web browser. I'm going to show you all just to kind of top things out. So if you don't have Git installed, then you need to install Git first. Look it up for however your operating system works to figure that out. Usually on Ubuntu, Debian type OSs, it's apt-get install Git, for example. But once you already have that, you run this command, git clone, and the Git URL of the repo. It's basically repo plus .git. And that just means download the code on the GitHub repo at this address. So if you do that, now you have PulseChain Validator. Cool. Oops, not LD, LS. And now you have these scripts. So to run these scripts, you may need to make them executable. So if you don't make them executable, they may be read or write only. And you want them to be executable. Those are three main permissions on Linux: read, write, executable. So if you need to make them executable in order to run the scripts. So to run the script, do that, and then whichever one you want to run, PulseChain Validator setup. And then you should be able to run it. And when you run it again, I'm not going to try to run it on this because I don't know if it's actually going to work. I don't want to go through all the errors, but when you run it like this again, you need to give it your Ethereum fee address, again, where you want the fees to go, and your server IP address. So for example, you could just do, whatever it is. So this is your fee address. Address is space your IP address of the server. So whatever that is, I'm just going to do random IP address. That's all I do. It's not even a valid one. There you go. But put in your server's IP address. And that's what you would do. And you just hit enter. And it may prompt you once or twice to hit enter when you're installing Rust. I think that usually pops up. But it should be very little user interaction. You just put that in. / just means run this file after you make it executable, setup, and then your fee address, and then your IP address. Those are the two parameters you need to run it. Then you hit enter, and it should work. So I'm not going to hit enter. I'll just hit Control-C. I just want to show you how that works. And again, if you want to know how this stuff, what it maps to, this is, again, the fee recipient. These parameters are just going to the different configurations for the clients. So I've just automated all the manual stuff that you need to do as far as the client setup, or again, 85% of it. And when you run this script has been tested on Ubuntu 22.04. So if you use a different Ubuntu version, it may or may not work. If you use a different Linux OS, it may or may not work. If you use a Mac or Windows, Godspeed. I didn't write any documentation for those. Some of the stuff may work, some of it may not, but Linux is the server OS. It is the gold standard. That's why every cloud provider says, hey, I'll give you a Linux VM, because they know it's very repeatable, scalable, and supported in a lot of different ways. And if you're using the cloud, you don't have to use the cloud. There's advantages. Everyone screams decentralization, don't use the cloud. Well, all the devs are using the cloud. I would wager, I don't have all the stats in front of me, but I would wager a good percentage of the validators the devs are going to be running are probably going to be from a cloud service, because advantages they provide, 100% uptime, 99% uptime, they take care of all of that. They take care of all the utility bills, electricity, all that. And it's just easy to spin them up. It's easy to use Terraform to come up with a configuration for your infrastructure as code type of stuff. That's again why PulseChain devs talk about Terraform and all those templates. It just makes it easier, and it has a lot of advantages there. And if you're worried about decentralization for cloud stuff, there's like 10 different cloud providers. You don't have to use AWS. You could set one up in Google Cloud. There's Oracle Cloud. There's Microsoft's Cloud, Azure. There's IBM Cloud. There's like DigitalOcean. There's a ton of different cloud providers. And within each cloud provider, there's different regions, different basically data centers that you can set up for them to run in. So you can set up validators in 10 different clouds in 10 different regions for each one if you wanted a little bit more redundancy. But I guess the worry there is just, what if the providers decide to turn off the switch for all the ones that are running Ethereum validators or PulseChain validators or however? Well, then, that would be a good case for running your own hardware or making your own data center, like Alex from Hedron. We still need people. I definitely hope not everyone uses the cloud to do their validator, but I think a good portion of people will. And I think that's okay, as long as there's a good portion of people who are running their own hardware as well. Anyways, just some pros and cons. So after running the script, the script automates around 85%, like I said. The two major steps, maybe 2 or 3 major steps: generate your validator keys with a deposit tool. I should probably link the deposit tool in here as well. But that's available at, let's see, GitLab.com, PulseChain.com. So do not download and use the Ethereum one. Use the one at the PulseChain website, because the Ethereum one is the one that a lot of people go to. I first tried to use it too, but this is the one made with the PulseChain magic sauce and stuff. So this is the client should be using to generate your things. So again, generate them on a different machine, and various reasons of why to do that. I actually link a security video in the repo as well on the README that you can check out. It explains a lot of this stuff. Very cool. I need to finish it myself, but he talked about a lot of very important themes for validator security. Shout out David Feeder for sharing that on Twitter. That was super useful in order to understand all these concepts. So once you generate them, you need to get them over to your validator server. You can use, just like SSH, there's secure copy, SCP. So you can copy them over the network. I like a little trick that's like, basically makes it copy and paste. So you just base64 encode the zip file of the validator keys, and then you just decode it on your server. I like stuff like that. Just cute little trick you can do if you like literally just want to make a copy and paste style. And then once you set up the deposit client, make sure to do the setup, because that was one thing I ran into. I had the V3 one and I downloaded the new one, but I didn't do the setup, and I tried to generate the keys for V4 and it wouldn't work because it installs libraries and stuff on your system. So you actually need to run the setup, make sure everything's installed if you're trying to go from V3 to V4 as well. And then deposit.sh, create a new mnemonic and give it the chain ID or not. If you don't set it, it'll ask you during the thing, during the setup, and then just follow the instructions from there. Once you have them from there, again, you need to, you need to import the keys as the user that's running the nodes. if you're using the cloud, your default user is going to be Ubuntu. But with this script, we set up a new user called node user. So when you import them, make sure you import them with the node account and not your Ubuntu account. Otherwise, it won't show up when the validator runs. So we have instructions on exactly what to do here for that. And then you can exit that shell. Once you start a shell as a node user, do the import, enter your password for each of the validators, then you can exit back to your Ubuntu user if you're using AWS for this. Or if you're just using your own hardware, whatever user this is, it'll be the same concept. And then you just start the clients. Once you're there, once you got your keys stuff, you start them. However, you do need to wait. It's recommended, unless you want to get slashed, to wait until all the clients are synced before you make your deposit. It's 32 million T-Pulse per validator. You could have 1 validator, 10 validators, 100 validators. I've heard plenty, Gamma's talked about 100 validators could be run on one server. I haven't personally tested that, but I think it makes sense. As long as you're, got your hardware right, you may need a little bit beefier server than the one I talk about here. But I think the one I talk about here is M2 2x large. It's 32 gigs of RAM, 32 or 64 gigs of RAM, 4 or 8 CPUs, and then everything does at least 2 terabytes of memory to do the blockchain sync, or 2 terabytes of hard disk space. So as far as, that's a common question, how many validators can you run? If you happen to be a huge sacrificer and you can actually you actually have enough 32 times 100, then that's something you may need to beef up your hardware, but you can probably afford it if you stack that much in the first place. And then once you make the deposit at Launchpad, and after it's synced, again, wait till it's synced, then make your deposit, else you risk getting slashed. And then it should take around up to 24 hours to get your validator activated and participating on the network, and you're good to go. So here I have a bunch of debugging stuff, a bunch of commands to check the progress, what this stuff actually means. This is where you are syncing. This is where we want to be. And then those numbers can change and stuff, but some stuff to help you debug if you can't figure out what all this stuff means. I really hope in the future to make this stuff easier. I think especially once we have validators in a box, maybe Alex from Hedron will make them. If it's just plug and play, everything just works. You don't have to worry about it, but we are in the early days of validating. So this is the manual commands you can use to try to figure out what this stuff means. And I forgot to mention too, this is all for Geth, aka GoPulse, and Lighthouse. I played around with Prism and Aragon before, but this script uses Geth and Lighthouse, and all the commands are kind of specific to them. So I don't know much about the other two. I have a few notes, but this is stuff I've tested. I know it works. I know how to figure this stuff out. Peering problems and all this stuff too. So that's on the talking to the client side. On the service side, to see what is actually going on, to look at the debug logs and stuff like that, you can use these commands. You can talk to so we created a system. The script creates system configuration files, which basically just make it easier. You don't need to be connected with a terminal. They just run. There's a service manager that runs the clients for you, and you can talk to the service manager to get statuses. You can restart the services, Lighthouse, Beacon, Geth, all that stuff, and you can see what's going on. You can see, what's syncing, the new blocks, whether your validator import is working, whether it's activated, sort of all that stuff, or see if there's problems as well. So there's also an EC2 helper script. I mean, it's very minimal. It's just like stuff that I think makes the experience a little bit better. You can name it something that's not just a generic host name, Validator, or anything else you want. And this just kind of makes it be quiet and kind of update your system, reboot, make sure you got the latest and greatest before you start validating. So Don't really need to use it. Just some of my preferences I thought I'd put in a script to help people out there. And it's not really specific to EC2 either. You can use it on your own box as well. Let's see. And then I've got a bunch of other stuff too. This is AWS. So these are Google Docs I created before during the validator streams I've been doing. This tells you exactly how to create a cloud account, what different things you need to do, what the different configurations are for the boxes, how to create a key pair, how to do firewalls, again, the storage, launch the instance, and then different stuff to different references that may be helpful as well. And then another doc, I just linked to a bunch of these docs. So like more how to use exactly, a lot of stuff I already put on the README, but how to exactly use the key management stuff, all that. Disclaimer, none of this is like use at your own risk. This is not audited code, all that stuff. Audited commands, it's just been my experience going through all this stuff. And then my long form notes, I published some of those too, long form notes on the different clients and setup. Again, I have the most experience with Lighthouse and Geth. However, there are some notes on Aragon and Prism that you may find helpful as well in there. No support on those because I stopped using those in favor of the other two. And then monitoring, if you want to set up stuff like that, there's some guides to do it. I don't have any scripts on it currently. And this is how to set it up for Grafana for more secure access. The commands you can use as well for that. So a little bit of nerd magic going on. And then I've linked to some of the community guides. If I missed any, feel free to let me know. I can throw them on there too. These are the ones I've came across and found helpful. And I know David has a V4 one I believe he released recently too. This is a security one. Highly recommend everyone watch that. The guy's very interesting and goes over a lot of cool stuff. And the FAQ. So just some of the common questions I talked about here. And you can see like kind of some troubleshooting as well, just some light stuff. And if you're doing all this stuff, you really should be in a chat room for people to help you and for you to help other people and share ideas and stuff. So feel free to do that. And these are all just a ton of references of things I've came across to help me better understand how to be a validator. With that being said, I'll put on FAQ and we'll just briefly go through the code. I went through the code before explaining everything in another stream. So I won't go through too heavy this time. I literally went line by line last stream. I won't go too heavy. These are just comments on a lot of stuff I already have on the README, but I kind of like to make scripts stand alone by themselves if someone doesn't have access to it. So I did that. You can change the name of the node user to anything you want. Feel free. I just made it node because it's very generic and talks about what it does. And then this is the chain we're using. Different clients like to have it different ways. Be careful with that. That's something you may come across. Why isn't this working? And because some use underscore and some use dashes. Fun. Love problems that you're sitting banging your head at for 30 minutes trying to figure out because it was just a slightly different naming convention. These are the app packages that gets installed for dependencies for all this stuff. The different directories where we keep data, blockchain data, and where we're pulling from on the repos, and checkpoint URL to make things sync faster and stuff too. Again, when you run the script, I've timed it a couple times. It takes sometimes it takes 20 minutes, sometimes it takes 40 minutes. So yeah, I settled on it takes around 30 minutes plus or minus, depending on your bandwidth, server specs, if you run into errors, things like that. And the first step, it installs the different packages and sets up Golang and Rust for you. So the clients will work. So it does all this stuff, generates your shared secret for the clients to talk to each other, adds your user. That was the second one. Step 3 is just sets up the Go Pulse and gets it to start syncing. Some interesting things I had to do here to make this work smoothly in a script. Not very important, but took me some time to debug it, to say, hey, I need to slow down a minute to get this script to work better. And then this is the system service it creates. All the guides you look at will have some kind of skeleton version of this to show you what to do. And this is just an automated way of putting into a file for you. And then reloading stuff so it can start running. Step 4, setting up Lighthouse. So the only thing with Lighthouse, because you need to sync the blockchain and you need to make your deposit before it actually starts working, then I guess I should better word this of you can start it. Actually, yeah, I guess you could start it and let it start doing stuff so it starts syncing before you make your deposit. So yeah, that could be a little improvement I could do there, but not a big deal. Just funny, all these like little things you come across when you're reading your own code and seeing how it works again. And then this is just some little tricks to make all this stuff work. And then we start doing the beacon service, and this is where your IP address goes in because it needs that. And your fee recipient, your ETH address, goes here. Again, boot nodes, Brett, the PulseChain dev, recently told me this may not be necessary anymore. It helped me a lot in V3 to get peers and stuff running. However, in V4, maybe it's not necessary. So, I mean, it still works with it in there, but maybe it get removed at some point. And for your beacon service, or for your validator service. So you have your Lighthouse beacon service, your Lighthouse validator service, and you have your Geth on the execution side. And that also has your fee recipient. And yeah, this is just, again, just some script magic to make all this stuff work. And step 5 is to open your firewall on your local machine. If you're doing this AWS, you also need to open your the main firewall, the security groups they call it, and get these in there as well. But I have docs on that on the reference on the README to talk about the firewall on the AWS side. So you need to do this on the local side. At least do it if you're using AWS. At least do it on the global side. But if you're running your own hardware and stuff, you probably need to do this on the local side as well, depending on how the default configuration is, whether it's default deny and allow and all that stuff. Doesn't hurt to do it anyways. And then this just tells you what you need to do afterwards. And you're good. So if you run it and you come across errors, then you can start debugging what those errors are. But I've had many successful runs with it, and yeah, my validators seem to be working fine. After, it takes a while. First, you got to sync everything. That takes a day or two. Then you got to wait to be activated, which takes up to a day usually. So it can take around 3 days to get everything synced and be validated on the network and all that stuff.